All right. 11 through 11, 12, 13, 14, 15. 11 through 15. Number 11 says the two box plots represent the low temperatures in Temple, Texas. The temperatures from 2000 are represented in the top box plot, and the bottom plot represents the temperature in 2010. Based on the two plots, which statement is not correct? So I don't expect you to do this on your test, but I'm going to go through and label everything on these box plots just kind of for some review. Okay, so let's look at the one that's 2000 first. We'll start from the left to the right, just like we read a book. So this is the least value. This is the greatest value. Then we go quarter one, quarter two, quarter three. Quarter one, quarter two, quarter three. Now remember, it's not actually quarter. That's just to help you remember that it's called quartile. Okay? So we can actually go ahead and put those. I'm going to go ahead and write those values on there because it's just going to make the whole problem easier, honestly. So the least value is 6. Quarter one looks like it is 14. I'll write it right there. Quarter two, which is also the median of the whole thing, or the middle, is 20. And quarter three, that's coming, boy, that's hard to tell. Honestly, can't really tell. You know what, I'm going to call that 23. Technically, it's between, it's honestly hard to tell, but I'm going to call it 23. And then the greatest value on that one is 27. All right, I'm going to change colors. And let's go to 2010. We have the least, quarter one, quarter two, which is also the median of everything, quarter three, and the greatest. So the least for 2010 is 8. Quartile 1 is 11. Quartile 2, hey, stop. It's my dog, sorry. Quartile 2 is 17. Quartile 3 is 20. And the greatest value is 28. Okay, so now this should make the question pretty easy to answer. I don't know what's happening here. I don't know. Whatever, I don't care. There, let's just do this. There, I'll just turn it completely sideways. Based on the two plots, what statement is not correct? So we're looking for something that's lying. It's like, isn't there a game called Two Truths and a Lie? So technically we're doing 3 truths and a lie because there's 4 answers. So somebody's lying. It's either A, B, C, or D. Okay, so A, the median temperature in 2000. Now the median means quartile 2. Okay, I'm going to change colors so we can know the difference. Let's go red. The median, meaning quartile 2, the median temperature in 2000 appears to be about 3 degrees higher than in 2010. Okay, so 2000, it's right here. So in 2000 it was 20, and in 2010 it's right here, which is 17. So is 23 degrees higher than 17? Yes, it is. So that's true. So it cannot be A. B, there were about 25% of the temperatures that were below 17 degrees in 2010. So let's only look at 2010, and we're looking below 17 degrees. Okay, so remember, each one of these sections is 25%, even though, yes, I know, they look like they're different sizes. But remember, each section is 25% of the box plot. Okay? So there were about 25% of the temperatures that were below 17 degrees in 2010. well, here is 17 degrees. This is 25%, and this is 25%. So is that true? Was 25% of the temperatures below 17 degrees? That's not true. Actually, 15% of the temperatures. So that is false, or you can call it a liar if you want, whatever makes you feel better. Okay? Now realize that being in middle school, you found the answer. It's B. You're just going to stop there. I get it. I'm down with that. I'm all good with that. I would do the same thing. But for review purposes, I'm going to go over C and D. C, on average, the temperatures are higher in 2010 than in 2000. So here's the problem. You actually cannot find average using a box plot. But if we kind of look, is 2010, the greatest is here, which is a little bit larger than in 2000, and the greatest is here, which is a little bit larger than 2000. So does that tell us that if we were to just estimate, yes, about the average temperature was probably a little bit higher in 2010? That's really not a good question, honestly, because you can't find it. I know, I probably just confused you more. It's okay, I confuse myself all the time. I can't deal with that. There we go. D, the range for 2000 is greater than the range for 2010. Range is how far apart something is. Okay? If I'm in Salado and you're in Moffett, we're, 25 miles apart? That would be the range. Anyways, it's how far apart something is. D, the range for 2000 is greater than the range for 2010. So let's find the range for 2000. Remember, we have 27 and 6. So it's how far apart is that? So you just do 27 minus 6, which is 21. Okay, so the range for 2000 is 21. And then you look at 2010, and we labeled it. So we've got 28 and 8. And you just find the difference in those two. 28 and 8. You can just subtract, which is 20. So the range for 2000 is greater than the range for 2010. That is true. So therefore the answer is B. Okay. Number 12. Kristen surveyed all of the students in art about their favorite class this semester. The results are shown below. From these results, Kristen concluded that art was the favorite class among all the students at her school. Is her conclusion valid? Why or why not? So, Kristen surveyed all of the students in her art class about their favorite class for the semester. So she says that Kristen concluded that art, there we go, art is the favorite class among all the students at her school. So this may be a bit of a silly question. You probably already know the answer. The favorite class among all the students at her school. Let's go ahead and answer that now. Is her conclusion valid? No, it is not. Let's look at how many students are apparently in this, I guess, art class. Because all she surveyed was art. So how many kids are there? 10, there's 20, 30, 38, 48, 52, 62, 65. There's 65 total kids. And how many favorite was art? It's only 20 out of 65. Why or why not? Because only 20 out of 65 actually picked art. Okay, this is technically an easy question, but let's talk about it a little bit. Is this what phrase would you put underneath this? Like, is it 50%? Is it 25? Is it below 50? Is it above 50? What are you thinking? This is below 50. Below 50%. If we wanted to find the percentage, what could we do? Don't forget that this right here, it just means to divide. You've seen it typed before. This right here means 20 divided by 65. Isn't that just a fraction? Yes, which is the exact same thing as what that is. So to turn that into a percent, you could do 20 divided by 65. I'm wondering who likes that? Who thinks that looks like an easy question? I'm guessing nobody, right? So what if we simplified this first? What if we did divided it by 5 and did, what is that, 4 over, what, 13? 13. So would this be an easier problem? 4 divided by 13? Yeah, it would. And to figure that out, to turn it into a percent, you already know, just add a decimal and some zeros and divide, and that'll tell you what your percent is. Okay? Let's go to number 13. I'm running out of time on my thing. Anyways, 13. Mr. Brown is deciding whether to add an orchestra class to the band program. His decision will be based on a survey of a sample of students attending the school. Which technique will provide Mr. Brown with a random selection of school students? So it has to be completely random. Okay? So if you were to let's think about what he's talking about. He's talking about orchestra class, right? I'm going to put in a new orchestra class. So if you were to only survey everybody in band, is that random? According to the little short story. What's the short story talking about? The short story is talking about orchestra, playing instruments, right? So surveying just people in band that are already interested in playing musical instruments, is that going to give you a random selection for a survey of an orchestra class which also plays random instruments? No, it's not. Okay. So let's look at B. What about going to a PE class and surveying all of those kids? Is that completely random? It's actually not. Why? Because you're choosing a class, you're only choosing specific kids in PE to survey. It has to be 100% random, like reaching into a bag and pulling a marble, which is random. C, survey every 8th grade every 8th grade student to enter the school. Is that random? No, because technically you're still picking certain kids. You're picking 8th grade kids, and that is not random. Look at D. Survey the first 50 students to enter the cafeteria at lunch. That's random. Okay, maybe at this school, they're all mixed in for lunch, like I used to be when I went to school, back when we didn't have electricity. So survey the first 50 students to enter the cafeteria. You could have a 6th grader, you could have a boy, you could have a girl, an 8th grader, a 7th grader. You could have somebody interested in band or somebody that hates band, right? That is completely random. Okay, so it has to be 100% random, plucking something out of a bag without looking. Okay, and that's what would happen if you just surveyed the first 50 students to enter the cafeteria at lunch. Let me see if I can get one more done on here before my time runs out. The dot plot below shows the number of siblings that students in Miss Salih's class have. Number of siblings. Okay, so what percentage of the students have at least 2 siblings? At least, that means 2 or more. Okay, so that is right here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 that have at least 2. Okay, out of, we already know that's 10, so this is 11, 12, 13, 14, 15. Out of 15. 10 out of 15. Let's simplify that and make it just divide by 5, and that is 2/3. Okay, and 2/3 is one of those fractions or ratios that you should just know what percentage is. If I give you $100 and you split that $100 between 3 people, what is each person going to end up with? Each person, 1 out of 3, is going to get $33.33. So for 2 people, 2/3 would be $66.66 as a percent. I made it. Yes, sir. All right, we'll see you on the next one.